All right, so we're going to talk more about sequences. Remember, sequences are what we talked about in class today. It's where we have a n, so we'll have like the first term is we'll have n equals 1, second term n equals 2, and we go on as far as the sequence goes. So there's something called an arithmetic sequence, and that's what this word is, arithmetic. And a sequence is arithmetic. Okay, that sounds a lot like arithmetic, right? So a sequence is arithmetic if the difference between consecutive terms are the same. So if we have a sequence like this, 1, 2, 3, 4, dot, dot, dot. Well, between each of these terms, the difference is 1, right? Okay, so that's an example of an arithmetic sequence. So a sequence is arithmetic if there is a number d such that d is equal to a2 minus a1, and that's equal to a3 minus a2, that's equal to a4 minus a3. So you see what I'm doing is just taking a term and subtracting the previous term, and that has to equal the next term subtracted from the previous term, and equals the next term. So all of them are the difference between all of them is the same. And so that can continue on forever, and we can say that a sub n minus a sub n minus 1. And that's just saying that whatever term we have, we're going to subtract the term before it, and that common difference, okay, d is the common difference, is always going to be the same. That's what makes it arithmetic. All right, so find the common difference d of the sequence. So real easy. Okay, 4, 4, and 4. So d equals 4. And that's all we're doing right now. Okay, how do we find the nth term of an arithmetic sequence? Let's say that we have this pattern right here, and I say, well, okay, well, this is the first term, this is the second term, third term, fourth term. I want to know what the 57th term is. Well, that's not so easy because we don't have time to write it all out. But there's a formula for that, and the nth term of an arithmetic sequence always has this same form. And it's a sub n, so whatever term we're looking for, a sub 23 or a sub 67, is always equal to a sub 1, the first term, plus n minus 1 times the common difference. Okay, and this is, if we learned about earlier in class, an explicit formula. And in this formula, a1 is the first term. Okay, d is the common difference, and n is the term. So it's the first term, or it's the second term, or whatever. All right, so real quick example, find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. Well, they tell us right there the first term is 2. The common difference is 3, right? So we want to know the formula for the nth term. So our formula says a sub n equals a sub 1 plus n minus 1 times our common difference. So the formula for this specific sequence is going to be a sub 1 plus n minus 1 times 3. Well, that 3 can be distributed in there, so we're going to get a sub n equals 2 plus, remember we'll distribute this 3n minus 3. Now we have a 2 and a negative 3 that can be combined, so a sub n equals 3n minus 1. And that is our formula for the nth term of this arithmetic sequence. And all that means is if we were to make a xy table, but instead we made an n a sub n table, we can start to find our points. When n is 1, we already know that a sub n is 2. When n is 2, well, we plug it in here. We get 3 times 2 is 6. 6 minus 1 is 5. Okay, if n is 3, we could plug it in. 9 minus 1 is 8. And you can see that our common difference is 3, like it's supposed to be. Now that's not very useful to find the first three terms, but that'd be really useful if we needed to find the 73rd term. So if we needed to find the, let's say the 20th term, plug in 20, 3 times 20 is 60, 60 minus 1, 59. And we didn't have to do any of this plus 3, plus 3, plus 3 stuff all the way down. All right, another quick example. We're going to write the explicit formula and the recursive formula for the nth term of an arithmetic sequence with terms 35, 23, 11, and then we're going to find the 43rd term. So that sounds like a lot to do, right? Well, let's start out with what we know. We know that our a sub 1 equals 35. Okay, we have a sequence, so we can determine our common difference, right? That is negative 12, right? So our d is negative 12. And now our formula says to come up with our explicit formula that we're going to do a sub n equals a sub 1 plus n minus 1 times our common difference. So a sub n equals 35 plus n minus 1 times negative 12. Well, we'll distribute that negative 12 and get a sub n equals 35 minus 12n plus 12. And so our formula is going to be a sub n equals negative 12n plus 47. All right, that is our explicit formula. Now we're going to do our recursive. Okay. Remember, we know that a sub 1 equals 35. And we know that our common difference is minus 12. So we could find any place we wanted, a sub n, if we knew the number that came before it, a sub n minus 1, and we subtracted 12. So that's our recursive formula. Now, we're supposed to find the 43rd term, right? Well, the 43rd term is going to be easier to find with this explicit formula than with this one, because we don't, to find the 43rd term, we would need to know the 42nd term, which we don't know. So, 43rd term, we're going to take our explicit formula and write a sub 43 equals negative 12 times 43 plus 47. Okay, so negative 12 times 43 plus 47 is negative 469. Okay, so don't worry, this will get easier. All right, another example, find the 9th term of the arithmetic sequence whose first two terms are 2 and 9. Well, if 2 and 9 are our first two terms, our common difference is 7. Okay, our 9th term, that means a sub 9. So we know a sub 1 equals 2. We know our common difference equals 7. So we'll do our formula a sub n equals a sub 1 plus n minus 1 times our common difference. Well, a sub 9 equals a sub 1, which is 2, plus n minus 1, so 9 minus 1, times 7. So 9 minus 1 is 8. 8 times 7 is 56. 56 plus 2, 58. Okay? Now, we could have taken this part right here and wrote out our formula, right? It's 2 plus n minus 1 times 7. Distributed all that. A sub n equals 2 plus 7n minus 7. A sub n equals 7n minus 5, right? That would have got us our formula. But this worked just as well. Here we would have done a sub 9 equals 7 times 9 minus 5. So that's 63 minus 5, 58. All right, we're just going to keep going with the examples because this is one of those things that we got to do enough of them that you can actually think about them. All right, so the fourth term of an arithmetic sequence is 20. So a sub 4 equals 20. A sub 13 equals 65. Write the first three terms of this sequence. Well, a way to think about this is what these numbers mean. So the position of these terms, we have the 13th term and we have the fourth term. If we subtract them, that tells us there's 9 terms between them. Now our actual terms are 65 and 20. Well, if we subtract them, that tells us that there's a change from the 13th term to the fourth term of 45. Well, our common difference is going to be our term values divided by our position values, or the change in those values. So our terms are 45 and our position is 9. That's how much change is happening. So 45 divided by 9 is 5. So that tells us what our common difference is. Now, to find our first three terms, well, if we know a sub 4 equals 20, then a sub 3 is 15, a sub 2 is 10, and a sub 1 is 5. We can just take that common difference and work backwards from the fourth one. All right, last one. Find a formula for the nth term of the arithmetic sequence with a sub 4 equals 18 and a sub 11 equals 53. Then find the 56th term. Well, a sub 4 is 18, a sub 11 equals 53. So we'll subtract our positions, we'll subtract our term values, we'll divide them, get 5. That's our difference. That's our D, our common difference. So find the 56th term. Well, we need to do this. A sub 1 plus n minus 1 times D. But we don't know what a sub 1 is. But we do know a sub 4 is 18. So that means that a sub 3 is 13, a sub 2 is 8, a sub 1 has to be 3, and that's because of our common difference of 5. So a sub n equals 3 plus n minus 1 times 5. This is my explicit formula for any term. Okay, so I have a sub n equals 5n minus 2. That's my magic formula. Now, to find the 56th term, 5 times 56 minus 2. So a sub 56 equals 278. Okay, so that's it. Hopefully that was not too much too fast, but if it was, don't worry, we'll have plenty of time to talk about it tomorrow.